Hello, this is Kyle from Remas. How can I help you?
Hey Kyle, how are you? I'm looking for some apartments in Cityville.
Hello, I'm doing well. Thank you for asking. It's great to hear that you're looking for an apartment in Cityville. Could you share your budget range for the apartment and any specific features you're interested in, like the number of bedrooms or bathrooms?
No, I just want to know the most affordable one.
Got it. The most affordable apartment option in Cityville is located at 404 Cedar Lane. $260,000. I take 50.
Perfect. Do you have another option, or that's the only one that you have under 300K?
I have another option for you. There's an apartment located at 404 Cedar Lane, priced at $260,000.
Okay.
It has two
Can we see them both? Like schedule something and see them both?
Absolutely. I'd be happy to help you schedule viewings for both apartments. First, let's check your preferred dates and times for these appointments. Do you have any specific?
This agent uses RAG methodology under the hood. That means that it's fetching information efficiently in vector databases. In this fragment of the conversation, we see how these AI agents can retrieve properties from the knowledge base and help the customer really understand and find their ideal property. This kind of agents add a lot more of value and can really optimize businesses' operations. In this video, we're going to learn how to make VAPI use the RAG methodology under the hood to make your AI agent serve a lot of different use cases, just updating the prompt and the knowledge base. So now let's remove the knowledge base and see how this assistant would perform without it.
Hello, this is Kyle from Remas. How can I help you?
Hey Kyle, I was looking for apartments in Cityville. What kind of properties do you offer?
Hi there. We offer a variety of properties in Cityville, including studio apartments, one-bedroom units, and larger 2 or 3-bedroom apartments.
All of this is hallucination. None of this is specified, and the agent is speaking by itself. That's the difference between a robust agent and an academic one. As we noticed in the first scenario, the agent was much more intelligent and provide accurate data. And in the second case, the agent completely hallucinated. Basically, that would be a disaster. So if you want to have a robust agent like this one, this video is for you. In this video, we're going to cover creating a knowledge base, uploading it to Trieve, VAPI's vector database provider. We're going to integrate it with VAPI via API. We're going to do this in our HTTP client like Postman, but don't worry, we're also going to cover how to do it via n8n. And then we're going to manually add it to our VAPI assistant, and that's it. Just following those steps, our assistant will be much more capable. This is incredible because this is what makes our AI agent be able to cover a wide range of complex industries such as healthcare. So let's get started. Going to this chart, we see how VAPI leverage providers to create quality voice agents. For example, it sends the prompt to OpenAI or any LLM to power the communication. But also in this scenario, we're going to see how it uses knowledge bases via their provider Trieve, that is a vector database provider. Leveraging those providers, they are able to create quality voice agents. But let's dig deeper. So before going hands-on and creating the database, let's see a high-level picture of what having a knowledge base really means. Because VAPI, at the end of the day, is a chatbot with extra capabilities, applying speech to text and text to speech, and being able to connect to phone providers. They are able to supercharge a chatbot and make it a voice agent. So let's go to this example. So a customer reached our real estate agent because it's interested in buying a house. The assistant received the phone input, translate speech to text, reformulate the prompt with the system prompt and the message of the customer, send it to OpenAI. OpenAI will generate a response based on the assistant system prompt and also the message of the customer. And VAPI will analyze that response and optimize it to sound normally when translated to speech again. So that's why it sounds naturally to type to a VAPI assistant. So once they have translated the text to speech, they just broadcast the audio to the phone receptor, and that's where our customer will just hear, sure, let's schedule a call with one of our top realtors. Perfect. So here, with a plain assistant, with a good system prompt and the correct set of tools, we can book meetings, for example, as I shown in this scenario. But this type of agents won't handle more advanced scenarios, where the value is going to be really provided by the agent itself, reducing the human time involved in this operation. For example, if the customer asks, hey, what type of properties do you offer? The assistant won't know how to handle that. So we're going to have to add that in the system prompt that is not scalable at all, and potentially make the assistant hallucinate. So let's see how we build this virtual realtor for one of our clients. In this case, the customer will ask something more detailed. For example, I would like to rent a house. What kind of properties do you have to offer? So let's see how the flow looks. First of all, it will start very simple, just grabbing the customer message, translating it to text. But instead of just reformulate a prompt with that and system prompt, we're going to add a step here. And here is where Trieve enters in the scene. Basically, here's where we're going to apply the RAG methodology, because before reformulating the prompt to send it to the LLM, first we're going to search relevant information in our vector database. We're using vector databases because if we want to use a normal database and just send a huge chunk of text to the LLM, that would be the same as adding everything in the system prompt. That's why we use vector database, to optimize the amount of tokens that we're actually going to send to our LLM. So a very simplified way to explain vector databases are that we're going to have a spatial matrix where we're going to store records based on their similarity. For example, wolf is similar to dog, that is similar to banana. That's why it's stored in this left side of the matrix. This is stored just as a number that with retrieval algorithms, we can get only the relevant information stored based on what the user asked. So, being that said, now we understand why we're getting this kind of numeric value instead of the relevant information of what the user asks. So, the next step that Trieve does is recover the original text of this embedding. This is called an embedding. It's the way that we store the information in our vector databases. Trieve recovers the original text that in this case would say something like, we offer apartment, houses, and condos to rent or buy. Now, having this information, the VAPI assistant has the question of the customer, the assistant system prompt, and it has a memory. We have a whole knowledge base that we can provide answers from, but we're doing this in a very optimized way because we're just adding the relevant information of that knowledge base to our actual prompt that we're going to send to the LLM. Here, VAPI gathers all this information, reformulate it, and send it to the LLM. The LLM will have much more context, especially more context on your client's specific business. If you go to ChatGPT and you ask what type of properties X company provides, it won't know. Here is where we are really adding value because we are adding information, specific information about the client businesses. The LLM now is going to generate a much better answer because that answer will be taking in account the customer question, the assistant system prompt, and the knowledge base context. The rest of flow is the same. VAPI will analyze that response, optimize it to match the assistant communication style, translate it to speech, and broadcast that audio to the phone receptor again. So in this example, we're going to say, hey, I want to rent a house. What kind of properties do you have? What we retrieve from our vectorized database is we offer apartments, houses, and condos to rent or buy. Our final result is that our customer will hear, do you want more information about a particular property type? And here the conversation will keep rolling. And the advantage of this scenario is that instead of our phone assistant just booking a virtual call with one of our clients' realtors, they're directly going to book a house view, and that optimizes the business operations a lot. In conclusion, this assistant can support much more complex use cases and perform better with a most cost-efficient relation. So let's create our knowledge base. This information is going to be separated in chunks. We can divide the information in a particular way to optimize that chunking. This is just optional. You all absolutely can just, upload the manual of a product or just a description and information about a business. But in this case that we're going to use this knowledge base to search different properties, I decided to separate information in this format. First of all, we have just information about the business, a bit of context of the content, and the listing of the properties. Then we absolutely can have any additional information or any additional note to customize even more the system. So let's go to Trieve and start this process. So here, first of all, let's create a data set. Here we're going to say real. Here we have extra configuration that we can check what VAPI recommends in their documentation. But basically, they suggest to use this model that is hosted by Trieve. Here we can select the algorithm to find similarity in our vector database, but keep that as it is and just create a new dataset. Perfect. So the first thing that we have to do is create a new API key. Let's say VAPI real estate. Here you can customize, but you can go ahead and generate it. And let's save this value. The next thing that we have to do is set Trieve as our provider in VAPI. So with this API key, let's go to VAPI dashboard, set provider keys. Let's set search for vector databases here and just paste your API key. Perfect. Okay, that's done. We can continue this process. So let's upload our knowledge base file. Here, this is all optional, but let's have something like real estate agent. Select the file. So the next step is just upload and chunk files. If everything went well, we're going to see this green label here, and let's click groups. Okay, in this example, I uploaded a small database, so we have just a couple of chunks created, but we can customize that if we want to. So great, now we have our datasets created in Trieve. So the next step is integrated with VAPI. Let's go to API keys, and here you have to copy your private key. Do not click this because this is the ID. This happened to me. Do not click this because you're just copying the ID of the key. You have to visualize it. So we're grabbing this key to be able to interact with VAPI API directly and associate the Trieve dataset that we have just created to our VAPI account. So you just go to your HTTP client. Here I'm using Postman. Don't worry, I'm also going to show how to do this in N8N if you don't have access to HTTP client. Basically, now we want to create a knowledge base. So here in VAPI API reference, we just going to copy that value and paste it here. This must be a post request, and you can grab the body from the documentation as well. Here. So just copy this, and here, let's customize the name. Real estate agent knowledge base. And here is where we have to go back to Trieve and copy the dataset ID. Put it here, and with that, our knowledge base has been created. Now, if we go to our VAPI dashboard, here we have this knowledge base that we can select, and that's it. Just click publish. Your assistant will be able to have this functionality.
This is Sarah from Remaz. How can I assist you today?
Hey Sarah, how are you?
Hello, I'm doing well. Thank you for asking. How about you? How can I assist you today?
Yeah, I want to rent a property, but I was wondering what type of properties do you offer?
We offer a variety of property types, including houses, apartments, townhouses, and condos.
Oh.
Are you interested in any specific type of property for renting?
Yeah, I'm interested in apartments.
Great choice. We have several apartment listings available. Do you have a particular location in mind or any specific features you're looking for?
I want to know the price of the cheaper one.
The cheapest apartment we have available is located at 404 Cedar Lane, Cityville. It's priced at $260,000 and includes features like a city view and energy-efficient appliances.
Okay.
Would you like to schedule a viewing for this?
Great. So now we see that our voice assistant is giving much more value to our client than just booking appointment to see the client's needs. Here, we are automating completely that part, and our client realtor are starting the conversation with the customers once they have already booked a house view. So now let's see how we can do the HTTP request using N8N. Here, we're going to create an HTTP node. In this HTTP request node, we are going to select the post method, use the VAPI knowledge base URL, In authentication, put none, but specify headers. And here we're going to send directly the authentication header with your VAPI API private key. Also going to send body with raw body content type, but the content type has to be application JSON. And here we're going to do the same thing. Get the dataset ID and replace it here. Perfect. So that's why I strongly encourage you to create knowledge bases for your voice assistant, making them much efficient, cost-effective, and much more productive at the end of the day. Just adding this extra step to have custom information of the business, we are going to be able to provide a wide range of much more advanced solutions to our clients. And that's all. That's how you can create this kind of assistant for your real estate clients, or just tweak them a little bit for your own business use cases. Thanks a lot for watching the video, spending your time understanding how this kind of agents works under the hood. Please let me know in the comments if you have any doubt or anything that you would like us to cover in our next video. Being that said, thanks a lot. See you in the next one.